Soup is sold in tins which are filled by a machine. The actual weight of soup delivered to a tin by the filling machine is always normally distributed about the same mean weight with a standard deviation of 8 grams. The machine is set originally to deliver a mean weight of 810 grams. So we know that it's normally distributed 810, 8 squared. Determine the probability that the weight of soup in a tin selected at random is less than 800 grams. So we want the probability that x is less than 800. So straight to the calculator. We want continuous normal CDF with, so less than 800. So the lower is going to be negative infinity, and the upper would be 800 with a sigma of 8 and a mu of 810. So that needs to be negative infinity. I thought I put negative infinity in, but never mind. So 0.1056. Determine the probability that the weight of soup in a tin selected at random is between 795 and 820. So now we want between 795 and 820. So we can make the bottom one 795 and the top one 820. And that's 0.8639. Actually, just looking at the value there, if I round that correctly, it won't be 39, it will be 40. So, moving on. The weight of a particular variety of orange is normally distributed with mean 205 and a standard deviation of 25. A wholesaler decides to grade such oranges by weight. He decides that the smallest 30% should be graded as small, the largest 20% graded as large, and the remainder graded as medium. Determine to one decimal place the maximum weight of an orange graded as small and then medium. So this is an inverse normal, which I'm not completely clear is actually on the syllabus. Clearly it was on the test last year, so I'm going to show you how to do it. We go to the inverse norm, and the smallest 30% would be to the left. Remember what the normal distribution looks like. So the smaller values are down here, so that's why it's to the left. And they're telling us that it's 30%, so that's a probability of 0.3. And the standard deviation is 25, and the mean is 205, and that gives us 191.9. So 191.9, and then the largest 20%, so they're graded as large. So we'll do the same thing, and inverse normal. This time it's going to the right, because what we've got is a situation here where anything up this way is large and these ones are medium. So the value we're after is this one here, and that is the largest 20%, so a probability of 0.2. This is 25, and this one is 205. Okay, that would be 226.0.